So in this question, they actually give you the graph. And on the graph, we see a backyard space, which is this. Hold on. So this is the backyard, right? The space around. And then what's the green area? This is the lawn. So the lawn area is formed by, how did they form the lawn area? What did they do? They joined the midpoints of the adjacent sides in the quadrilateral. So they found the midpoints and they joined it, and we have to prove that the lawn area, so this area here, is a parallelogram. So how do we prove that something is a parallelogram? So to prove that it's a parallelogram, we have to see that the opposite sides are parallel. So for example, side JK would have to be parallel to what? ML, correct? This side length has to be parallel to this side length, and then this side length has to be parallel to this side length. That's how we're going to prove it. What are we finding to prove that something's parallel? How do you know if something's parallel? By the slopes are equal. They're the same. So first things first, in order to find the slopes, do you know this coordinate? I have to find the slope of the line JK. Do you know the coordinate of J, and do you know the coordinate of K? Did they give that to you? No. They did not give it to you. You can look at the graph, but I actually want you to find it. J was formed by the midpoints, yes, of PQ. So we have to find all the midpoints. Midpoint, this is the midpoint of QR. This is a midpoint of R, I cut it off, what was it, RS? And then this is the midpoint of PS. So we have to find the coordinates of the midpoints, because we need those coordinates to find the slopes, right? So go for it. So to find midpoint J, I use the coordinates of P and Q, and I found the middle point. So midpoint J is 110. That's the coordinate of midpoint J. Midpoint K, you're looking at the coordinates between what? Q and R. Good. Midpoint L, you're looking at the coordinates between R and S and R. And then for midpoint M, you're looking at the coordinates P and S. Did you get midpoint K is located at 9, 5? Okay, midpoint L is located at the coordinate 5, -6, and you can go back to the graph to verify, does that make sense? And midpoint M is located at -3, -1. So we have the 4 midpoints. We have 4 coordinates that are formed by the lawn. How are we going to use this information to prove that it is parallel, that it's a parallelogram, I mean? We're looking for the slopes now. So we're going to find the slope of JK and the slope of ML, right? If those two slopes are the same, then we know those two sides are parallel, and then we're going to find the slope of MJ and KL. And if they're the same, then we know those two sides are parallel, and that will prove that it's a parallelogram. So just to reiterate, we're finding the slope of what? JK, y2 minus y1 over x2 minus x1. And we want to see if that is parallel to which slope? ML, thank you. So you're going to find the slope of ML. And then we want to see that JM, right, is parallel to KL. So you're finding all those slopes. Okay, so if we have the slope as a fraction, -5/8, or I can write it as a decimal, doesn't matter for this because we're just trying to compare the two. And then we're going to see if slope ML is equivalent to that. So it would be -1 minus -6 over -3 minus 5 is 5 over -8. Is -5/8 the same as +5 over -8? Yes, because when you reduce it, or when you turn it into a decimal, a negative and a positive makes a negative, and then a positive and a negative also makes a negative. So we know that, yes, these two sides are parallel. We have to prove if the other two sides are parallel. Okay, so this one is negative 11 over negative 4. If I turn that into a decimal, it would be positive. No, it's negative 11 over negative 4 because negative 3 take away 1 is negative 4. Right? Negative 3 take away 1 is negative 4, so it would be positive 2.75. And we want to see if KL is equal to that, if it's the same slope. And it's the same thing. Negative 11 over negative 4 is positive 2.75. And I've organized this to see that these two sides are parallel and they were opposite each other. And then these two sides are parallel and those sides were also opposite each other. So is this a parallelogram?
Yes.
Yes, it's a parallelogram. Yes, parallelogram. And this is how we've justified it. We've proved